Practical 3 of our Excel sessions, we are going to cover the following topics. Firstly, we're going to look at discrete probability distributions, the first one being binomial, Poisson, and geometric. We will split these into 3 different videos so that it is easier for you to work through each one separately. So let's first click on the first worksheet, which is the binomial distribution, and let's quickly recap what a binomial distribution is and how the Excel function features. So we know that we can calculate either exact probabilities or cumulative probabilities, as we have been doing in the lectures, and we used the binomial tables. Excel can do exactly the same, calculate both exact and cumulative probabilities. The advantage of using Excel is that we are not limited to the tables that we are given. Okay, very often you will find that you will be given a sample size of maybe 400 or 200, and we do not have tables that extend that far. So let's look at what the binomial function looks like. Firstly, we got to type in equal to binom.dist, and these are the following arguments. X represents a specific value of a random variable. Your n and your p are your parameters, and true and false will now indicate whether you are to calculate an exact or a cumulative. If you are calculating an exact probability or outcome, you will use false, and true if you will are trying to find a cumulative probability. But please note that it has to be in the form of the probability of x less than equal to some small x, just as we had when we were using the binomial tables. So let's quickly look through this example. According to the American Academy of Cosmetic Dentistry, 60% of adults believe that an unattractive smile hurts career success. A group of 50 adults are interviewed. So very quickly, let's try and determine what distribution this is. They have given you a probability. A probability can be represented as a percentage. So this is going to be 0.6. And it represents the adults who believe that an unattractive smile hurts a career success. So we have one of two outcomes. It's either going to hurt your career success, that is an unattractive smile, or it will not hurt. So hence, we've got a success and a failure. Then we are also given a group of n adults. N adults, there's your sample size. So N and P have been given to us, where P represents the probability of some success. So clearly, this is a binomial distribution. If you go through all your 4 or 5 properties, you will see that all have been satisfied. So we start off by defining the random variable. And this is very important, okay, as you proceed. Also, look at the way the question is phrased, and that will help you define your random variable. The first question said, what is the probability that 18 of the adults believe an unattractive smile hurts career success? Now, let us define X to be the number of adults who believe that an unattractive smile hurts career success. In our question, that value was given to us, or the probability of that was given to us to be 60% or 0.6. So hence we know that X is a binomial. There's my N and there's my P. The question is asking for an exact outcome, meaning 18 adults. So we are looking at the probability of X equal to 18. If you used your normal PMF, and if you put in all your values, this is what you would get. If you tried going to your tables to try and help you work this out, you will see that you will not have tables. But also try putting this into a calculator. You will see that it is too large. So this is where Excel can be very useful. What is the function? So equal to binom.dist, and now we've got to put in all the values. X, what is X? X is what we are calculating, probability that X is equal to small x, our parameters, and then true and false. Now, because there are so many arguments, I suggest you use the insert function. So let's type in or click on insert function and type in binomial, press enter, and you will see that it gives you quite a few options. Here, binomial.dist is what I want. Click that. Now, it prompts you and it tells you what it is asking for. So the first one, number underscore s, is the number of successes. So the number of successes that we are looking for here is clearly 18. Next, trials. Trials is the number of independent trials. So this is going to be your sample size. That is 50. P is the probability of a success. We know that the probability of a success is 0.6. And then it tells you, use true if you have cumulative, use false if you have an exact. So ours is clearly an exact probability. We type in false, and that now gives us the probability. Okay, so use insert function, very helpful. The second part says, what is the probability that at most 34 of the adults believe that an unattractive smile hurts career success? So what is the question now asking us? At most 34 means 34 must be the most number. Hence, we are looking at x less than equal to 34. So remember, this is cumulative now. In order to use cumulative or to find a cumulative probability where we are going to use true, we must have it in the form of less than equal to. This is in the correct form, so we may proceed. So again, let's click on insert function. Binomial distribution appears on the top. Let's say OK. Now we want to find the probability that x is less than equal to 34. So 34 is going to be the number of successes. Trials again doesn't change. That's my n and my p. These are my parameters for my binomial distribution. But now, because this was cumulative distribution function, use true. Hence, we've got to type in the word true here. Click OK, and this is the probability that we have obtained. The last question. What is the probability that at least 23 of the adults believe that an unattractive smile hurts career success? So, at least 23. What is at least? This is the probability that x is greater than equal to 23, meaning 23 must be the least number, the smallest number. So hence x greater than equal to 23. But now remember, in Excel, again, we cannot find a cumulative probability in the form of greater than equal to. It has to be in the form less than equal to. So we're going to use the property of the discrete random variable where we know that the sum of all your probabilities must add up to 1. So what would the probability of x greater than equal to 23 be? This is going to be 1 minus the probability of x less than equal to 22. Remember, this is a discrete random variable. So again, how do we then find this out? Let's calculate it. Binomial distribution, okay. And we've got 22 trials. Again, what are our parameters? Our n and p. And is this cumulative? Yes, it is. So we're going to put true. Okay, so that gives us an output of this. But remember, we have to find 1 minus the probability of x less than equal to 22. So all we need to do is go up to the formula bar where we want to edit, and we're going to insert a 1 minus. And now we can press enter. And this gives us the probability that we are interested in. Hope you found this video useful.